You're full of pretense.
Kita ni ada siapa inci, betul soalnya sudah itu kan, kalau kau inci okay, mana dia tu? Nasib kita bercerai, kasih dia, iya, kasih. Balik ke cem, inci kerja. Kita akan ceng. Ada orang kayak ini kau tengok. Ba, mana ni kita ada anak. Aku sama sih. Mana? Sungguh cuma abal ya. Siya cuma nectar. Ini lah. Ah, Macam gimana itu? Yang bahwa apa itu ya? Jadi mau baik sih bukan? Iya. Niki kira. Ini kira. Haba, cuman masalah orang seperti hanya suka, kamu berkesan. Saya tidak apa saya tidak itu. Saya tidak itu.
Me tell us about it. I was saying that we have gone that long. I think that's your prediction. Yeah, that's fine. Who was best for you? I will consider it. We saw the other man as well. You need to go. I love since kind experience with struggling just 1 year. And based on what I do, I could do it, but social media market right now is advanced and there are like a lot of things I need to learn. So you can understand that. It's only if you're very careful because I need something to, at least take a visit and make it before I can start to take for social media. Not money for take and go. No, the funniest, I will appreciate that. The truth is there are courses of like I want to take. Yeah, but I did but take care of my G so that so when I realized that because I had an experience also when I was in school. Oh my god. Yeah, foolish. Foolish of activities. Yeah, so I don't know the day. I just remember that type of teaching. My street. Because I have experience teaching. Has you came from experience?
No,
Like, yeah, yeah. So
I don't want this. How can I remove this so that because it's blocking the slide? Because the last time I worked with it, this was not there.
This was not there.
You can remove it so that all they will just be saying is this instead of they can hear my voice.
Yeah, the competency when it comes to education to me.
If you
feels
can
like it's very
remove or put it,
yes, it's because I
move it
have
elsewhere.
right for a very, very try to do something about it when it comes to communicating with us. I get so much anxiety and I get so much I get overwhelmed because I have different options that I can try it out. I think this is also a problem I'm shaping. So I have this person to shape it by one of the reasons that I'm trying to do. So that's like my example. At the point I felt
There's no option here.
Okay, to
more like
let me see.
trying to help people.
You see,
Personally, what I'm interested in it. Yeah. So, personally, I'm interested in technology.
okay, no problem. I'll use that and I'll use my
I don't want to see.
my tablet. And you see, like the last one we did, none of this was shown. Is the one they will just see that this it's interfering. Do you get it?
Yes.
So okay, don't worry. I'll just continue like that.
Yeah.
Oh my God! Please, oh, this thing is. Is it? Is the battery life okay?
It's a power cable. It removed.
Maybe just take it from here. Yeah.
It's just a process that like, okay, I've got to the professional state, my experiences, what gives me so much joy, that's a concern.
Okay.
for the kind of-
So
First and important, so it's in field of education. Well, I'm looking at them to me, I'm really something I'm willing to do for free. I'm doing this thing, I'm not going to eat. Yeah.
you're welcome, everybody. So I think we can start. Good morning. Are we waiting for the others? Because I can see a lot of the 9 o'clock people here. Are we waiting for the others? Should we wait 10 more minutes for them to be here or should we just continue? Those of us online, are we okay? Can you hear me? Hope, hopefully, this time will be better than in the morning. In the morning, we had serious glitches, but it's okay. So let's just wait for, if we have 2 or 3 more people joining us, that's fine. So those of us online, we are just waiting for the on-site people. If we have more people around, we can proceed. Are we okay with that? Just wait a bit. We'll be fine.
Please, how many of us here are from the morning session? In the morning session?
Where is the money section?
No, I mean, the second session.
This second one, two,
Only one.
How many of us for second, 11? Okay, so we're trying, okay, yeah, for 11.
Yes,
Okay, 11.
we have 1, 2, 3, 4,
And there are
5.
5.
That's fine, we can start. But it's not tough. I think most people have not come down from Holiday Mountain. Okay. You are most welcome. And for those of us that are just coming for the first time this year, meeting for the first time this year, I'll say Happy New Year. And so this is the concluding part of this module, which is deep learning. And we have been having a very nice time so far. We've learned so much, and we're just going to try to go through this model evaluation and optimization so that we can maximize the good performance of our models. In a nutshell, that's what we are trying to do. And like I said earlier, is that when we have this in mind, we want to evaluate and we want to optimize, we use parameters. And in deep learning, they are called our hyper parameters. We use different parameters. We try to make sure they are in place. We tune them and make sure they are at par with what we want to do with our models. And so for that, we are starting off by explaining what our hyperparameters are. Now, in explaining our hyperparameters, in the first class, I'll just repeat it in this next class. When we say parameters, because a lot of people have been asking me, oh, what are parameters? What are hyperparameters? When you say I'm tuning it, what are you doing in actual fact? So when we talk about our parameters, I use this analogy in the 9 o'clock class. I said, if you want to light a fire, you want to generate fire, there are some things that are needed. If not, that fire will never be generated. That's why you cannot create a model or be able to optimize a model if these parameters are not in place. And using the fire, we agreed that there are 3 components. Remember that triangle that we always see when we talk about fire? There are three components. There has to be oxygen in place, there has to be heat in place, and there has to be fuel in place. And then when these three collide, they come together, what do you have? Fire. Now, when these parameters, these hyperparameters come together, you have a model, and then you cannot talk about evaluating the model and optimizing the model. And so we'll just go straight and talk about our hyper parameters. So our hyperparameters, they are actually adjustable parameters in deep learning models that are set before training. And they play a crucial role in determining the performance of a model. Remember what we said? We are looking at the performance of our models. When we say the performance of our models, what do we really mean? We're trying to understand how well it can predict the outcome of the task that we have told it to do. Remember, when we are talking about this, we are referring to our machine models. Do you understand? Deep learning models, machine learning models. These are the models we are referring to. And so, the key hyperparameters in deep learning that we are going to be looking at, we have about 6 or 7 of them, and the first one here is our learning rate. And then if you read carefully, it says the learning rate is what? It determines how quickly the model learns from the training data. How quickly the model learns from the training data. That's what you mean by your learning rate, the speed at which learning takes place. This is what you look at. This particular parameter is what you look at. And it ranges from 0.01 to 0.001, giving us a float variable type. When we are coding, we have a float when we are discussing this particular kind of hyperparameter. The next one we are having is our batch size, the batch size. Now, when you are having a sample that is to be processed, it is actually processed in batches, not singly. And that is what is referred to your batch size, the hyperparameter. Remember, we are trying to see the individual parameters that you have in your learning model before the training. Okay? The next major one we are going to consider is our batch size. And here we say that it determines the number of samples that are processed together as a single unit before the model's weights are updated. I hope we still remember our weights and our biases. Okay, fine. And then the range is from 32 to 512. Next, we have the number of hidden layers. Hidden layers is coming up here again. Remember what we discussed about our hidden layers. And the hidden layers determines the complexity of our model. The more hidden layers you have, the more your model can analyze complex problems. Do you get it? But then you have to be careful so that your layers do not lead to what? Overfitting. And then the range here is between 1 and 5. And then next, we'll look at the number of units in the hidden layers. I hope we still remember our mesh diagram, so to say, in quotes. And then we have our different nodes, which are actually our different neurons. When we are talking about our neural network, we are looking at that structure of the neural networks. And then you have the number of units in the hidden layer. The same, it determines the capacity of the model. Increasing the number of units can improve the model's ability to learn complex relationships. I hope you know the relationship pattern in our structure, okay? The neural network structure. And then next, we are having our activation function. Now we have three different types of activation functions there. Remember, we talked about the activation function tackling different kinds of classifications. And what are the classifications? We have our binary classifications, our non-binary classifications, our in-betweens. And so these different kinds of activation functions, they tackle the different ones. And they determine the output of each neuron. The kind of activation function you use for your model will determine the output that you are going to get. So it is necessary, that's why we learned about activation functions in depth. It is important that you do what? Know the different activation functions, know their different specific capabilities, and know when to apply them when you are training. And then the next hyperparameter, remember, don't forget we are still talking about our hyperparameters. The next one is our optimizer. And here it says it determines how the model weights are updated during training. That is the function of this particular parameter. So we are putting, you remember the fire analogy, we are putting everything, every one of these parameters in place. Remember what we talked about our deep learning is actually neural network. And you know how complex the neural networks are. So we are not having just three factors like fire. We're having a complex structure here. And so all these different parameters will come into play when you are trying to evaluate and when you are trying to optimize your model. Are we okay? All right. So the optimizer, these are the common types of optimizers that we have. And next we have our regularization. I spent some time to talk about the regularization here. When we talk about our regularization, our drop rates, you know, so far we have been trying to consider what? We've been trying to consider how we can guard against overfitting. Your regularization parameter can help you to do that. It determines the penalty term added to the loss function. I hope we still remember what a loss function is. Good. The loss function to prevent overfitting. And then you have your L1 and L2 regularization. In the next module, we are going to be dealing with this. You will know what your L1 and L2 regularization techniques are. Of course, it's a float because we are having our decimal points coming in there, and the range is between 0.01 to 0.1. Next, we have, just like I said earlier, our dropout rate. This dropout rate can also determine the proportion of neurons that are randomly dropped out during training. I tried to explain it in the last class. It kind of controls the proportion of inputs you have so that you will not run into overfitting. So we don't joke with these two. They are in place and they help. And then finally, we have our epoch, which we will discuss in depth in the next module. And this determines how many times the model sees the training data. Increasing the number of epochs can improve the model's performance. That may also increase the risk of overfitting. But not to worry, we have our regularization and we have our what? Dropout rates. By the time we are able to adjust those adequately, we will not have an issue of overfitting. Do we understand? Okay. Adjusting these different hyperparameters, twigging them is what we actually mean by our hyperparameter tuning. We are trying to tune these hyperparameters. Now, when we finish tuning it before the training process, and we go through that training process, now we want to evaluate our model. That's going to be the next major topic. We are now trying to evaluate our model, and there's a process for that. Okay, evaluation. What do we mean by evaluation? In a nutshell, we are assessing the model. We have put our parameters in place. We have tuned our parameters. And now we want to assess whether what we have done is in place. The diagram says good or bad. So if we evaluate our model, it is very good. What do? We go over to optimize it. But if there is a problem with it and it's not up to the standard that we want it to be, what do? We go back to our hyperparameters and tune our hyperparameters again, or we ditch it all together and begin to come up with new ones. Do you get it? So that we can have a model that meets the standard and the expectation of what we are trying to design. Are we okay with that? And then how do we evaluate our model? How do we evaluate our model? Now, to evaluate your model, we are going to look at some key aspects. And number one there is our evaluation metrics. And this provides a quantitative measure of the model's performance. When we say quantitative, I hope we understand what that means. And then we are going to be looking at the accuracy, the precision, the recall, the F1 score, the mean squared error, and then the mean absolute error. Mathematics coming into place. But I hope you know that when we are looking at the F1 score, even all the way down to the mean absolute value, these are actually mathematical functions that helps us to check the prediction performance of the model. And so what are we doing here? We're doing statistics here. And so we are looking at a quantitative kind of measure. We twig it and we assess it to make sure it is at par before we go ahead to the next stage. And what is the next one? Cross-validation. Cross-validation is a technique used to evaluate a model's performance on unseen data, and it involves splitting, that's dividing the data set into training and validation sets, folding, dividing the data into case subsets or folds. We are going to see the concept of folding and folds in the next module, so just keep that in mind. And then finally, evaluation, training the model on K1 folds and evaluating the remaining folds. We're going to be saying that all that concept as we proceed. But for our cross evaluation, there's something that I want to highlight there. Unseen data. This tackles with our unseen data, those data that are not visible in our hidden layers. So our cross validation tackles that aspect. And then next we have.
Okay, ma, is dividing the data set into training and validation? Can we say that the validation set is also can call testing?
Yes, they can be used. That word can be used. Validation set, the testing set, and then the training set. You can also call it the validation set. That's right. Are we okay with that? I hope you know we talked about our testing data, training data. Now we are talking about this set of data and this other set of data. But I hope you know that this time around we're talking about our hyperparameters, and then we're talking about this group of hyperparameters. So we use the name validation. Hyperparameters. All right. Okay. Are we okay online?
Someone said that you are a bit faster.
Okay, I'll take it slow from here. I had quite an experience in the 9 o'clock class, and I'm actually rushing somewhere. I want us to get to the application part where every one of us, but I can see that most of us here have seen that, but the rest of us will be able to. I want you to link onto that site and play around a lot with the content of that site, but it's okay. I'll slow down.
Have you closed that?
Sorry?
Have you closed your application form?
It's still far. This is a 16, slide 16. So I think I have about 20 something slides, but that's I'll be okay. But in-house here, are we okay? Okay, fine. Overfitting and underfitting. It cannot be overemphasized. Overfitting, underfitting. Let's go through it again. Overfitting occurs when a model is too complex and fits the training data too closely. And what will that result in? Poor performance on unseen data. We need to take it easy. We need to take it slow. We need to be thorough. Okay, not just choke the model with so much complex stuff, and then you are not able to see those, it's not able to work with the unseen data, whether you need them in the system or you need a kind of dropout process to be applied to the unseen data. Do you get it? All right. So the next one is underfitting, and this occurs when a model is too simple and fails to capture the underlying patterns in the data. When it's too simple, it does not have enough data. It does not have enough layers. And then it cannot tackle any form of complexity in the model. Do you get it? And then you are faced with this situation of underfitting. This, please, is actually a technique for evaluation. When you are evaluating, you have to put this into consideration. And like I said, you will always see loss function. You will always see activation function. And you will always see overfitting and underfitting coming up, these terms and these concepts coming up as you go along, understanding deep learning. Are we okay? All right. So let's proceed. And then here, just like we explained, you all know what hyperparameter tuning is. But what I'm highlighting there are the different techniques that you can use. That's what is coming in there. This you will see in depth in the next module. We're going to play around with this and see how it plays out. And then it involves adjusting the model's hyperparameters to optimize its performance, like we have already established earlier. Are we okay? Online, are we okay? Because we have already discussed the tuning of the hyperparameters. All right, so let's proceed. Okay. Now we have to select our models, choosing the best model for the set of candidates model from that set. You know, you have different models. After you have finished using your hyperparameters, you have different, models that have been created. You now select the one that is appropriate. And these are the techniques we use for selecting them. When we talk more about optimization and so forth, we'll go in depth in the next module. We'll be able to understand that. So next, Mr. Ode, I hope this system is not playing up again.
What?
No, don't worry, it's okay. I hope it doesn't do what it did earlier. Okay, then finally, for our model evaluation, we are going to be looking at interpretability, grammar, understanding how a model makes prediction. We want to interpret the way it makes the different predictions. And we are using two different techniques. We are using the feature importance, assigning importance scores to input features, and finally visualizing the relationship between the input features and the predicted outcome. These are the two techniques that we are going to use. Please don't worry about this for now, but we are stating it there. And so when we go further, we will look at them in detail as we go further. Now,
We go on second one, dependent, something dependence.
partial, sorry, my face is blocking it there. But I have backup. Partial dependence plots. Partial dependence plots. Okay? So next, we are looking at our model optimization. Remember, this week we are looking at model evaluation and model optimization. All right. So for the model optimization, it involves the improving the performance and efficiency of a trained model. The performance and the efficiency of a trained model. And I want us to critically look at the diagram we have there. We are gunning for best hyperparameters. Now, you will all agree with me. It's very generic and we all know this. Now, when you want to cook, let's use cooking for example, and you use trash ingredients, what is the outcome?
Trash.
You will have your food, all right?
Yes.
But you know what the quality that you're having. But when you use best ingredients, just like we are having our best hyperparameters, how can your hyperparameter become okay? How can it become okay for the model? How can you categorically say that these are the best set of parameters I'm using for this model? Because you have tuned your parameters. You have selected your parameters. It has gone through all that process. And you have done your evaluation. You have prepared your parameters. And so what you are looking at are the best set of parameters. Also, you are sure of the kind of model that you're going to be working with. And then look at the diagram there, saying model training using the best model parameters. But there's a way to do this. And that's what we are going to be looking at shortly. What are the techniques? What are the techniques used for model optimization? There's always a way to go about things. And the first one there is our pruning. This involves removing redundant or unnecessary weights and connections in a neural network. I like this because if you look at this, look at the benefit: reduced model size, faster inference times, and lower energy consumption. Did you see that? As simple as this pruning process is, this is what you now get in your model. So is this process necessary or not? We have several others that are equally necessary. And then we have quantization. What is this? It involves reducing the precision of model weights and activations from floating point numbers to integers. Do you use more memory when you are dealing with floats? Yes or no? Yeah. When you are dealing with floats, the system will have to handle the decimal points and the extra numbers. But in this case, you are trying to do something like what? You're rounding it. And that is, during this quantization, that's what you do there. In trying to optimize the model. You're welcome. In trying to optimize the model, it reduces memory usage and computational requirements. We are looking at efficiency here. So this process cannot be overlooked. Are we in agreement? Next, non-lead distillation. Training a smaller student model, just like I said in the first class, you are training, it's like you are doing, what's going on here? Something like prototyping. You have a smaller set, you train that and check and see how it performs, and then you cannot import what you have done to the bigger picture. Do we get it? All right. That's what this knowledge distillation is all about. And in the next module, keep an eye on it. You're going to be seeing offline distillation, online, and self-distillation. Okay, and what are the benefits? Smaller model size, faster inference time, and improved performance. What is the whole essence of this particular topic of today?
Model evaluation and optimization.
Performance optimization, like I said earlier, that's the whole goal, to make sure that your model is working at par and is giving you exactly the predictions that you expect it to give to you. True of us. All right, just so we know, so we are on the same page. And so we'll continue from there. Next, you have model compression, reducing the size of a model while preserving its performance. We have Huffman coding and arithmetic coding. How many of you have? Okay, I know a lot of you have not done coding before, but these are the techniques you use, and you're going to see more of this. And when you are doing those kind of, it's like, how do I explain it now? It's like if A is writing a set of codes that's designed using an algorithm to write some codes, okay? And then B is doing exactly the same thing. Yes. Did you see? I wrote it there. Preserving its performance. It's still performing, but see what's going on there. Remember, we're talking about optimization. These two different people are writing codes. The lines of codes, what you call your LOC, for A is 2,000. And for B is 1,006 lines of code. There's a difference, but they are doing the same thing. Which is more efficient?
1/6.
So when you are doing model compression, it is something similar you are doing. And that requires skill. And then you are going to be using this kind of coding to be able to achieve that. Do you understand? But those of us that are online and on site, but we understand from this example what we are trying to do when we are compressing the model. Okay? We are not making it lose sight of what is supposed to perform as the performance that is supposed to achieve. Do we understand? All right. And so what do we get as benefits? Reduced model size, faster inference time, and lower energy consumption. That's what we get at the end of the day. Next, again, we are talking about model what? Optimization. I just don't know. He will be the best person to say. Okay, next, just like I said, what are we talking about? How to optimize our model. And then the next major point there is efficient neural network architectures. This one I like because last week we looked at the different neural network architectures. And when we say efficient neural network architectures, we are talking about the kind of architecture, the neural network architecture that is appropriate for a particular model. You should know the type to use. Like I think online somebody asked about the generated adversarial network. And when you talk of generative AI, like ChatGPT, you're using ChatGPT and different other tools. What kind of network did you think they used to do that? And in that case, they are bringing two different kinds of network, combining it together to produce an artificial network that is actually similar to the original, but it's new and it's different. That's the whole concept of a generative AI, collecting from different sources and producing something more powerful. Before, it used to be just linear, but now we're having something more complex. And the complexity increases as you increase the hidden layers in a controlled manner. You have seen that so far. Do we understand?
Now for ChatGPT, is it possible that there is more than one architecture to do what it
Yes.
Because aside from generating like images, there's like
Yes, yes. It has. You remember we talked about hierarchy in, I think, the 2 classes back. We discussed hierarchy.
But we discuss hierarchy in terms of like in a specific model. The hierarchy in terms of trying to learn something from the data. Not using
All that.
different models and like hierarchy.
That's the different networks. Are you talking about networks?
So when you discuss the hierarchy, you explain that it's learn low-level information first before it starts moving to more complex things. That's why I remember like I was discussing hierarchy. There's
Layers.
Sorry?
So the layers.
Yes, in layers. So there's that hierarchy in the learning. But in this case, I think that hierarchy in this case probably be like which model to use based on the learning. So we didn't exactly talk about that then. So when you say
Okay.
hierarchy,
Are you trying to understand it from, in discussing the different network architectures?
No, I was just thinking that it's how deep ChatGPT looks. We'll probably be using more than one architecture to do like various things. Probably
course.
have, like one for generating pictures, one that's up to that works hand in hand to answer the questions or something like that.
Of course.
As I was asking.
Of course. ChatGPT is not using just maybe like convolutional neural network or just using the generated adversarial network. There are a combination of that. But I hope you know that we'll go deep into that, maybe from the next module and when you go deeper into the applications. When we talk about more, we'll talk more on the network architectures. Do you understand? We can extray that and see the way ChatGPT works and what is used to be able to get ChatGPT. It's very complex, but it's understandable. So what we are trying to say here that efficient neural network architectures, thank God we didn't say architecture, they are designed to reduce computational requirements while preserving performance, and these are the different types. And of course, they are a combination of different types. Do you understand? But the one that we are going to be particular about, we are going to be looking at our convolutional neural network. We are looking at our GAN and RNN. I hope we understand those ones. Okay, and then what are the benefits? Reduced computational requirements, faster inference times, and lower energy consumption. Almost similar to the last one we have. Still talking about optimization. Okay. Neural architecture search. I think we have just discussed that. Searching for the best neural network architecture to use, or a combination of several, just like you are particular about the best. There are some architectures that are not good enough for the model that you're using. And so you have to, that is why this aspect of model optimization must be considered and taken seriously. And though here we have our benefits there, of course, the requirements are reduced, faster inference time, and lower energy consumption. Next.
How does reinforcement learning help to search for the best neural network to use? That's what it says. This can be achieved through techniques like reinforcement learning and evolutionary algorithms.
Evolutionary algorithm and gradient-based optimization. Now, these are different concepts that we are going to be looking in depth into. Reinforcement learning. This is a whole new area on its own. Evolutionary algorithms. How many of you have designed algorithms before? There is the evolutionary type of algorithm. It's not just the basic algorithm that you know. We're going to talk, these are different concepts that we go in depth into, okay, as we go along.
I'm sorry, when you say the data and algorithm, I mean, none of us are not really like coding like.
That is why I am being careful.
Okay.
That is why I put the techniques there for the benefit of knowing that these are the techniques that you should use. Script, you just created an algorithm that helped you to do the coding. That's what you just did. And then there are different kinds of algorithms. One is now we are talking about evolutionary algorithms. So that's what I hope that when you go back, you try and read about this. So you get the balance in your own study, okay? And then you can bring it to class and then we'll brainstorm on it and argue about it and try to remove anything that is not correct in it. Unfortunately, this is the last phase for deep learning. But you can talk to me online. Is that clear? Did I answer your question?
Yes.
Okay. Mr. Aule, this one is better. I know it's better. No, it's fine. At least. Okay, so what's going on right now? Okay, so let's proceed. Why is season? No, I won't do this again. This that happened yesterday will not happen again. Is it yesterday or early this morning? Earlier today, it won't happen again. What's going on here? It's freezing. It's freezing. All right. Now we have looked at the different techniques. You see, it's freezing. It's getting to the point where I want them to run the applications.
Sorry, sir. I think this is where the viewers, what we are seeing. So nobody can actually have, you have to go to where your PDF is. System.
I don't minimize this. Okay. So go to the slide here.
PDF down. Yes.
Yes.
No,
Open to that you can adjust from here. I see. You can expand.
take it. I'm on the
Okay.
second to the last.
Which slide is that number?
Yeah, the 27.
27.
Just put the 27.
Can expand them that.
Okay, fine. This is where I was rushing to. Now we had a very fun time. Mr. Ode,
Should not be able to temper with it in this place.
Should not be able to.
Should not be able to move around in this side.
no, but it's okay. This is about the last one. But can they see it online?
They are seeing it.
Fine, this is what I want. Thank you, sir. No, it's okay. Fine. At least I won't touch anything. Okay. So this, I want us to play with this. And there's something I want to draw up from here. We brought these different AI up. If you look at them, please try to go to these sites. The first, let us start with the first one. Let us all go to that site. I'm trying to use this to describe the GAN architecture. I want you to go to that site. Yes, it's there on the screen for those of us that are not with our systems. I mean, their phones. You can see it. These are two AIs. I would like you to do it yourself, but you have the link, right? You have the link. Fine. On your own, you can do it. This was what we did in the morning. Those of us online, can we see the link? Good. You can scroll. And there are different images. There are different images. And then we are going to combine them. Sorry? And create, we're going to connect them and then create a new one. And remember what the definition of our GAN was. And then bring that is artificial. This particular AI captures that. And I want us to play around with that. Try and get more images, different, there are many types. There's not just that one that you can see. There are different types you can see. You see, did you connect? Okay, go down. Just go down. Okay, have you connected it? No, actually, no, it's loading. Let it load and then you see what you now get. You see how beautiful. Can you see what you got? It's a combination of these two giving that. And then we can have,
More images.
you get more images by clicking on the plus sign.
But can I combine?
On both sides. This is the
I
style.
want to combine, it picks the style from this one. Yeah, ties it to the.
Like to combine them. Don't combine.
Connect them. There's a link there that tells you to connect it.
I've done it in the first case, so I put it over. That is what
Okay, sorry. Which model?
that promise.
Getting something nice. Okay, take your time, please. We have time.
Well, your phone is fast, 1 hour, and
What did you get? Okay, it's still. Okay, please take your time. I think I should just slow down. Come on, what's wrong?
no, that's fine. The rating.
It's trying to generate a new one.
Exactly. Click on the image and the style. And then we combine them.
Yes.
Those of us online, are we doing the same thing?
Artificial.
Are they
This is
responding?
this is the image. It will just describe, how it's designed, whenever, and then it's conversion.
This is very good.
Yes. And it's very easy for making.
Okay, I don't know video soon.
Sorry?
I don't know video.
No, you can.
Is that can you work on video? Is that what it is?
Yes.
Well, that is for images.
Yeah. You can design your own for video.
Exactly. Anyway, that's why as you learn more as you go more into deep learning and all that, you should be able to do that. But what I am trying to bring out, let me allow the others to get there. You don't have to do only one. Do as many as possible and see so that you get a feel of the concept.
Like I was saying, you can add this time.
That is one site I would really, really want when we get back to our different locations. I want us to play around with that. And then there are instructions on that site that tells you, break it. Do you know how you design a software and you try to break the software and see whether you do all the wrong things and know whether it's really working well? Do you get it? Kind of like break it, change the images, tinkle around with that, play with it and see what the predictions of the AI will be. It will just blow your mind and give you some new insights of how powerful this is and how it works. And then it will give you more insight into the kind of architecture that you use to design that. Do we understand? The rest of us, are we there?
Yes.
Do you like the new synthetic image that you are getting? You don't like it. Somebody in the earlier class said, but this is not nice. Now, when you are dealing with hyperparameters, you can actually tune your hyperparameters to give you something more realistic. And then there's an aspect that says the selection of the architecture to use. That will now also come into place when you want to optimize it. But this one just shows us what we can do when we apply the GAN architecture to the model. Do we get it? All right. Those online, are you together with us? Please, what kind of feedback am I getting from online? Let me see the comments.
Yes, but not clear.
Okay. Not, of course, the artificial image will not be so clear. That's why I'm saying you can tweak your parameters. Okay.
There's another one that's yes.
Yes. Oh, good.
Another one saying we are following you.
Oh, good. Are we all on the same page?
Okay, the second one is actually very nice.
Okay, the next one is actually very nice.
Yes,
You are beginning to play around with it. Okay, are you on the second one?
Yes.
Okay, follow the link and see what's going on. And then the evaluation that was given to you, there's a breakdown
Yes,
of the
and
evaluation.
very nice. I brought a picture
Look at what the AI is telling you. Look at.
I don't understand.
Okay, hang on, please. Hang on, please. The rest of us, please follow the next link. Those of us online, follow the next link. Follow the next link. Don't do only one image, you do more. Please, those of us online, follow the second link and check the analysis and see if the analysis is okay. And then explore more photos, explore more pictures, explore many things and see. Just keep doing it. The evaluation okay?
Yeah, for the first one, it
Well, the second one is.
the second one, I'm still looking. It's getting some error. It's getting errors. It's getting errors on this one.
The second one is not, the evaluation is not good. I think the analysis
It's simple.
Not necessarily.
It's not detailed.
It's still okay. Like
Most of detailed. Oh God.
this picture I sent, it's an identifying the pattern of the language as a drawer.
You know, there's something about it kind of captures everything in sight
Yes, and it's actually very
and gives a thorough analysis. And then at the end of the day, there's something I want to explain there. Are we all on the second one? Did you see the detailed analysis? Now, you are going to run through a situation where you now have to apply what we discussed earlier. Dropout. Maybe you just want to analyze one image there. Did you see how many images analyzing? Analyzing everything. And so you now have to apply that dropout rate and regularization. You regularize it, and then there's a way you tweak your parameters so it zeroes it on the center image. Not because it's analyzing everything there at the background. Even there was one, it started analyzing necklace.
I think it would have been nice if they could had a place you could input prompts on the ones you wanted to pick from the image.
That's another aspect of. Did you people in the first introduction? Did you have anything about prompt engineering? Okay, maybe it will come as time goes on. But that's a different area. Prompt engineering, the way you structure your prompt, that's a whole new field on its own. Some of you might take up a career on that. Your prompt can make, by the time you impute it, no, this is just a tool you can use to play around with and understand the concept we are talking about. But when you are designing a model, when you are training a model, those things will come into play. All right. Are we good? And then the final one. The final one is very, very popular. It's called Quick Draw by Google. And then just go to the final one and see what Google is trying to tell you. Anything you put there, anything you draw there, the AI sucks it up. It is trained with it.
Oh, I know. It's computer keyboard.
No, please, reduce the volume. You see, that's in that picture. One of the things it's trying to tell you is that it's trying to tell you how the model learns. No, not too loud. Not too loud. But do you see what is it when you draw? Do you know what it's using to give you that reply? What is it using to give you that reply? It has at the background.
It's picking certain features.
It's picking what other people. You see everything that you're drawing. It's going to save it. It's going to save it, and then it will now have You have data sets, and then you use it to analyze what you have into it and tell me whether it is true or not. You see? And if you are wrong, we tell you, no, this cannot be it. Did you see the predictions? You see the predictions?
Or spoon, or arrow,
Now, when you do,
I see lightning, or name, or river, or dolphin, or rhinoceros, I see parrot, or bird. Sorry, I didn't guess it.
now, please, am I getting feedback from the students online? Please let me know.
Or bracelet, or clock. Oh, I know, it's alarm clock.
I have no clue what you're drawing.
Okay, please go through these sites. Try to understand. The more you do this, you try to understand how it is necessary for you to optimize your model. You will also know how it is necessary for you to know the kind of parameters you feed it with, to know the kind of neural network architectures that is good for some different kind of features, and then also to understand how your models are trained. You see, everything that you have drawn now, it has saved it. And another person somewhere in Zimbabwe or Australia will still use it. And then it will bring out this data and be able to predict. And then you see how powerful the whole thing now turns out to be. Right. So this is the time you ask me questions. Now, these are not the only learning tools you can get. If you go online, there are several, but we have to bring out these ones because for the purpose of this class. Okay? Am I getting anything from online? Nothing. Okay, they are okay. I want to believe they are okay. If it's too silent, it's either they're not understanding at all or they are understanding completely. Anyway, but so far, we have come to the end of deep learning. This particular module. The next module is going to be more interesting. You have more applications, and then you have in-depth knowledge on most of the optimizations that we've talked about so far. Okay? Now, I am going to give you your assessment. It's going to be multiple choice. Please, there's going to be a deadline for it. Quickly try your best to meet that deadline, okay, so that we can submit your assessment scores on time. And then finally, peradventure, you have any questions concerning all we have been learning and what you experience in your own private study, reach out to us, okay? And those of you that still are interested in being part of the collaborative center, just write down ccai@cosmopolitan.edu.ng. ccai@cosmopolitan.edu.ng. Do we have it? So send your interest to that email and they will respond to you, because that goes to them directly. In case you follow the link online and it's not, yes, it's not forthcoming, please send to that email and you'll get it. From the CCAI, we are just, okay, please don't be offended. We are just coming from holiday. So some people are still trying to wake up. And so when the school is in, sorry? Probably. So definitely things will smoothen out at least before the end of the month. Thank you very much for being such wonderful students to work with, and hope fully, we'll see more of you. Thank you. Thank you. The 11 o'clock was better than the 9 o'clock. Yeah. Sorry, the 9 was
9 o'clock program. I think we have some issues.
serious hitches, but it's okay. It's okay. All right, those of us online, thank you very much. Bye bye.
Thank you, Mom. Everything.
I think it's been Let's give the other. If you have an afternoon session, I mean for 11 o'clock session. Which group you are going to buy? If you see the yes. Yes.